Hi, my name is Pierre Rochelle, and I'm the founder and director of the Robotics and Computational Kinematics Innovation Lab at the South Dakota School of Mines and Technology. Thank you for viewing this video, which gives you an introduction to our lab and the work that we do. First, we'll talk about the Infinity Fan. This is a patented device that we designed in our custom-built CAD software to design spherical mechanisms. And here you see the first prototype done by Stacy Dees and John Ketchel. We have one motor which drives both the fan blades and a spherical 4-bar mechanism which is driving the oscillations of the fan head in an infinity pattern, hence the name Infinity Fan. Next you have Sphere Walker. Sphere Walker is a hexapod spherical 4-bar driven walking machine. This is a novel device, again patented in the US. And there you see the simulation of our Sphere Walker technology, and here are the students that worked on the project. Next, you'll see our very first steps with Sphere Walker, the first time the feet hit the ground. You see 6 legs walking for this machine, and they're only requiring 3 motors to drive all 6 legs. So it's very, very energy efficient. And again, these are the very first steps, so we're showing you the awkward motion. Now here we have the Sphere Walker revised prototype with fully autonomous onboard computing and control, navigating different terrains, obstacles. And as you see, it's able to make turns, and we do turning simply by changing the phase difference between the 3 different 4-bar mechanisms which are driving the 6 legs. 3 in contact with the ground at any point in time. So again, this is a completely novel device designed using our research results that have been implemented in computer-aided design software that we've written. With most walking machines, actuators and batteries make up most of the mass. So the Sphere Walker has advantages with respect to both of those. Next, we have MotoMaker. This is a project where we're using an industrial robot arm to do free-form additive manufacturing. So we've designed a custom printhead, you see here in a close-up view of the end, that we mount to a robot arm so that we can print full free-form 3D lattice structures while we extrude struts along the directions. So here you see MotoMaker, and right now it looks like a traditional 3D additive manufacturing FDM printer, adding material in planes, stacking up, and the planes are stacked up in the vertical direction against gravity. Now, in a second here, you'll see what's special about MotoMaker. Now you see what MotoMaker is able to do. Because the print head is mounted on a robot arm, we're able to print in any direction we want. We just need the right software and motion planning so that we can build structures. And now we're doing lattices. So what you see here is the MotoMaker printing out a lattice structure growing from the build plate. And again, we start in the vertical direction, but we're able to build horizontal structures without any overhang, with overhang, without any support materials whatsoever. And we're extruding along the strut direction, so we get much better structural integrity than struts that are sliced in an arbitrary horizontal direction like traditional additive manufacturing. And here's a close-up of the print head printing a lattice structure. So as you can see, we extrude along the direction of each of the struts. So we developed all the software as well as the hardware to support and realize the MotoMaker system. And here are a couple of examples of lattice structures done with that. Currently, we have a Yaskawa Motoman GP12 robot in the ROCKIN lab, and this is a new addition. So we just thought we'd share with you this robot. We just start to do some projects with this robot, just showing you its speed and its capabilities. It's got a 12 kilogram payload, and repeatability and accuracy are industry-leading performance. And here are some projects we've done with previous Yaskawa Motoman robots. Designing the robot system to play checkers, to solve the Rubik's Cube, and we have many more projects underway. So I have my contact information here, so please feel free to reach out to me if you have any interest or questions about the activities going on in the ROCKIN lab at the South Dakota School of Mines and Technology.